All right, everyone, let's get started. Welcome to Business Mathematics. Today, we're going to be building a really important bridge. A bridge between the, let's say, abstract world of pure mathematics and the very real, very concrete world of business strategy. We're going to explore how the elegance and, frankly, the predictability of mathematical functions can give us some profound insights into how the market actually works. For many of you, I hope today is the day that numbers really start to feel like stories, and the graphs we're about to draw stop being just lines on a page and start becoming what they truly are, essential tools for making smart business decisions.
So let's just jump right in. Have a look at this shape on the slide. It's a parabola. I'm sure every single one of you recognizes this from an algebra class somewhere in your past. But I want you to look at it differently today. What if I told you that a deep, functional understanding of this curve is the key to figuring out everything from the price of the coffee you bought this morning to a multi-million-dollar launch strategy for a new smartphone? That, right there, is the central question for our lecture today. How does this seemingly abstract mathematical shape directly and powerfully shape our entire world of commerce?
So here's our game plan for today. We're going to move through this very logically, step by step. First, we'll officially connect the dots between math and market principles. Then we'll do a bit of a deep dive into the story behind the curve itself. That's the quadratic function. From there, we'll take that knowledge and use it to build the most fundamental model in all of economics, supply and demand. Section 4 is where things get really practical. We're going to find the market's sweet spot, what we call equilibrium. And finally, we'll wrap up by looking at the real-world consequences, the very expensive pricing pitfalls, of what happens when you ignore this kind of mathematical analysis. Each section builds on the last, so let's get started.
All right, Section 1. Math meets the market. Just like the subtitle says, our goal here is to get from the abstract to the concrete. We're going to be translating the formal language of mathematics into the kind of practical, actionable intelligence you need to make sound decisions as a manager or an entrepreneur. You know, a lot of people think of business as an art form, something driven purely by gut feelings and intuition. And look, there's certainly a place for that. But what you're going to learn in this course is that the most successful, most durable strategies are almost always built on a foundation of data. This section is all about understanding that foundation, how we go from a pure theory to, hopefully, pure profit. Okay, moving into Section 2, the story of the curve. Here we're going to zero in on the main mathematical tool for today's lecture, which is the quadratic function. Now, it is absolutely essential that you stop thinking about this as just some dry formula you have to memorize from a textbook. For our purposes, I want you to start seeing the quadratic function as a kind of narrative device. It's a powerful tool that tells a story about how business variables change, how they reach a peak or a valley, and then how they change again. So let's get a formal definition on the board. A quadratic function is any equation that takes the form y equals ax squared plus bx plus c. Now the key feature here, the reason we are so interested in it, is that little x squared term. That exponent is what creates the curve. More importantly, it creates what we call a turning point, or a vertex. Now, why is that so powerful for business? Well, I want you to think about the kinds of questions you're going to face in your careers. You're always going to be looking for the optimum point. You'll want to find the exact price that gives you the maximum possible profit before it starts to fall off. Or you'll want to find the production level that results in the minimum possible cost per unit. These are not straight-line, linear problems. They all involve a turning point. And the quadratic function is the mathematical key that lets us model these scenarios and find those exact optimal points.
And when you put that function on a graph, this is what you get, a parabola. Now, whether it opens up like a U or down like an inverted U is all decided by that A coefficient from our formula. If A is a positive number, the parabola opens upwards. This shape is perfect for modeling something like average costs. Think about it. As you start making more of a product, your cost per unit might go down because of efficiencies, right? It hits a minimum point, but then if you try to produce too much, you hit bottlenecks, you pay overtime, and your cost per unit starts to rise again. See the U shape? Now conversely, if A is negative, the parabola opens downwards. This is the classic model for revenue. As you increase your price from zero, your revenue goes up. It hits a maximum sweet spot. But then, if you keep raising the price, you start to drive away customers, and your total revenue falls. You can literally see the story of your business just by looking at the shape of the curve.
Okay, so now that we have that solid mathematical foundation, we can move into Section 3. We're going to apply what we know about curves to one of the most fundamental, most important models in all of economics, the supply and demand graph. We are going to build, piece by piece, a visual picture of the core forces that are at play in any free market. I really want you to pay close attention here, because this graph isn't just something you need to memorize for an exam. This is a thinking tool that you will use for your entire career in business.
Every single analysis like this, no matter how complex, starts with this exact same canvas. It's a simple two-axis graph. Now, by universal convention in economics, the vertical axis, the y-axis, always represents price, which we denote with a P. The horizontal axis, the x-axis, always represents quantity, which we denote with a Q. It is absolutely critical that you burn this into your brain. Price is vertical, quantity is horizontal. Get that backwards and none of your analysis will make any sense.
So first up, let's draw the demand curve. The very first thing you should notice is that it has a downward slope. It goes from the top left down to the bottom right. This is a visual representation of what we call the law of demand. And it really just reflects a basic truth about how we all behave as consumers. All of the things being equal, when the price of something goes down, the quantity that we are willing and able to buy goes up. It's just common sense, right? If your favorite video game costs $90, maybe you'll buy one copy. But if that same game goes on sale for $20, you might buy one for yourself and 3 more as gifts. That inverse relationship, price down, quantity demanded up, is what gives us that classic downward slope.
Now let's add the other side of the story, the supply curve. You'll see its slope is the exact opposite of the demand curve. It slopes upward, from bottom left to top right. This represents the law of supply, and it comes from the producer's point of view. So I want you to put on your CEO hat for a second. If you found out that the price people were willing to pay for your product suddenly went up, what would you do? You'd have a massive incentive to make more of it, right? Of course you would, because higher prices mean you can cover higher production costs and, most importantly, generate more profit. So there's a direct relationship here. As the price goes up, the quantity that producers are willing to supply to the market also goes up, and that's what creates this upward slope. Okay, so now we've mapped out the two opposing forces in the market, what customers want and what producers are willing to sell. But the most powerful piece of information from this whole model doesn't come from looking at either curve by itself. It comes from looking at the single point where those two curves cross. And that brings us to section 4, finding the sweet spot. I really want you to think about that phrase for a moment, market harmony. We're not just looking for a random point in geometry where two lines happen to intersect on a piece of paper. We are identifying the one single unique combination of price and quantity where the desires of the consumers perfectly align with the goals of the producers. At this one point, the market is in agreement. It's balanced. It's in a state of harmony.
And here is the formal definition that you absolutely need to know: market equilibrium. It is that single point on the graph where the quantity demanded by consumers is exactly equal to the quantity supplied by producers. Think about what that means. At this price, there is no pressure for the price to go up or down. Why? Because every single item that was produced and offered for sale at this price has been bought by a willing customer. The market has been, as we say, cleared.
So, let's make this feel real. Imagine you are the product manager for a new gadget. Your market analysis team has done the research, they've plotted the curves, and they come to you and say, the data shows the equilibrium price is $19.99. Now that is not just an answer to a math problem. That is a powerful strategic recommendation. That number is your launch price. Why? Because your mathematical model is predicting that at this exact price you'll achieve that perfect balance. You're not going to be left with a warehouse full of unsold product that you have to pay to store, and you're not going to have frustrated customers looking at empty shelves. It is the data-driven price.
But what happens if you miss that price? What are the actual bottom-line consequences of just guessing or pricing based on a gut feeling, or maybe just copying your competitor instead of doing the math? This leads us to our final section, pricing pitfalls and strategy, where we're going to talk about the very real and very costly dangers of missing that equilibrium mark. So I want you all to really think about this for a second. Put yourself in the manager's chair. You have this graph, this data, right in front of you. What are the specific, tangible consequences to your inventory, to your revenue, to your company's reputation if you decide to set your price at, say, $25, well above that sweet spot? Or on the flip side, what if you price it at $15, well below it, when all the data screamed that the right answer was $19.99?
And here are the two outcomes. Honestly, this is one of the most common and costly mistakes that young businesses make. So let's be crystal clear. If you price your product above equilibrium, at that hypothetical $25, well, that high price is going to make you want to produce a ton of product, but it's going to scare away a lot of customers. The quantity you supply will be way higher than the quantity people demand. The result is a surplus. That's products sitting on shelves, collecting dust in a warehouse, representing capital you've wasted. Now, the opposite mistake.
You price below equilibrium, at $15. Your customers will love you. They'll line up around the block. Demand will crush your supply. The result is a shortage. You'll sell out on day one, which might feel great for a minute, but it actually represents a massive amount of lost sales, of lost revenue, and it just created a huge opportunity for your competitors to swoop in and satisfy all of those customers you left behind. Both are incredibly costly, and both are completely avoidable with the right analysis.
And that brings us to the crucial takeaway for our entire lecture today. It's this: business mathematics is not just some prerequisite course you have to get through. For anyone who wants to be a leader in business, it is a fundamental strategic tool. This supply and demand graph, think of it as your map. It gives you a logical, rational way to navigate the chaotic and competing forces of the marketplace, to avoid predictable disasters like shortages and surpluses, and to make your most important decisions based on data and evidence, not just on a whim.
So we'll end on this final thought for you to take with you. Today, we used a relatively simple model to find the perfect price for one product in a stable market. But this is really just the first step on your journey. If the simple intersection of two lines can give us this much strategic clarity, I want you to just imagine what other business secrets about maximizing production, about calculating investment returns, about charting sustainable growth are just sitting there, waiting to be unlocked with the more advanced mathematical tools you're going to learn in this course. That's the challenge, but it's also the incredible opportunity that lies ahead for all of you. Excellent work today. I'll see you all next week.